Hey, fifth graders. So I wanted to go over part of 3.2a. And then today's lesson, I'm going to have you watch a couple of videos from Mr. Trenda, who I think made some really nice videos for this unit. We might be watching some of his others in the days to come. But we're not going to do every problem in 3.2 or 3.3. But we're going to kind of go through both of those lessons today. First of all, 3.2a. I want to just talk about what you did for yesterday. And so your tables should have looked similar to this, and your graphs should have looked similar to this here. And the question was, what were patterns relating distance and time in the tables and the graphs? And one thing I would say is the bigger the speed, the faster the speeds go up, right? Or the distance goes up, sorry. And that would be shown in the graphs where you see this first graph here, right there, that's the 50 miles an hour. Let me get rid of the bracket. This is the 50 miles per hour. And a little bit faster would be the 55 and then the 60. And you can see how that 60, what we would call is being a little more steep in the graph. Okay, that is steeper. And if we had someone really speeding and then they went 100 miles per hour, you'd see that their graph would look more like that right there. And yeah, that's not legal, but maybe if you were a professional NASCAR racer or something, I think they go faster than that. But you could see the faster the speed, the steeper the graph. Now, there was the question of if you were at a distance of 6 hours, how could you use the table, the graph, or the equation to find the distance? So the only way you could do that with the table is to continue the table on and get to 6 hours. Let me erase those things. You'd have to continue the table, or and then just find out what is here for 6. Now, if we were thinking about the equation for each of those is 50 times time, or 55 times time, or 60 times time. And so we could take 6 times 50 and get 300 here. I make these extra marks for some reason. I don't know why. You could do 60 times, or 50 times 6 here. You can get 300. Or you could do 55 times 6, and that would be 110. That would be 330. Or you could do 60 times 6, which would be 360. All right. For a table, so that's kind of how you use the equation in a way and the table if you were to fill in the blanks there. The graph, you'd have to extend this to 5 and 6 and see wherever these lines end up, and then go down to 6 and then go over here somewhere to find out where that would be. Okay, so 6 was actually 300, so it shows that my little lines aren't very good. All right, so that's how you would use a table and a graph. Or you could do the opposite, guys. If you knew a certain distance, say you knew that distance, and you wanted to know how long it would take, depending on, say, your speed, you could just go that way until you hit a graph that you are looking for, and then down, and it would tell you how much time it would take. All right, so maybe that would be 2.75 hours if you're at 60 miles per hour. Okay. All right. Now, I think I'm going to stop there for a moment and then do another video for the next part.